Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing flow problems in areas and volumes. So in this question, we are told a different tank is a cuboid measuring 1.8 by 1.5 by 1.2. Water flows from a pipe into this empty tank at the rate of 200 centimeters cubed per second. Find the time it takes to fill the tank. Give your answer in hours and minutes. So first of all, let's find the volume of the tank. The volume of a cuboid, like any prism, is base area multiplied by height. And the base area is length times width, and then multiplied by height. So this is quite simple. All you have to do here is simply multiply the three numbers together. So we have 1.8 times 1.5 times 1.2. So 1.8 on the calculator times 1.5 times 1.2 gives us 3.24. This would be the volume of the cuboid. 3.24 meters cubed, because here this is in meters, this is in centimeters, so we're going to have to do a conversion. So in order to get the volume in centimeters cubed, we remember that 1 meter goes to 1 centimeter by multiplication by 100. Therefore, 1 meter cubed goes to 1 centimeter cubed by multiplication by 100 cubed, which is 100 power 3, which is a million, pretty much. So 3.24 times 100 to the power of 3 gives us 3.24 times 10 to the power of 6 centimeters cubed. Now the water is flowing in at a rate of 200 per second, and we want the time it will take to fill the tank. So the time is just going to be the total volume, which is 3.24 times 10 to the power of 6, divided by 200. So let's figure this out. 3.24 divided by 200. This would be 1.62 times 10 to the power of 4 seconds. Or simply 16200 seconds. 16,200 seconds. So we want the answer in time, in hours, and minutes. So how do we do this? You want to divide 16,200 by 60 to get the number of minutes. So let's do 16,200 divided by 60. We get 270 minutes. So the time is 16,200 divided by 60, and this would give us 270 minutes. And then we want to convert the minutes into hours. So 270 minutes, again, divided by 60. So instead of minutes, now we have hours. We have 270 divided by 60, which gives us 4.5 hours. They want the answer in hours and minutes, so we divide this into two parts. 4 hours, so the whole number alone, and then the decimal alone as well. So 0.5 hours, and then you multiply the decimal by 60 and go back to minutes. So 30 minutes. So the final answer would be 4 hours and 30 minutes. Let's check the marking scheme. 4 hours and 30 minutes is correct. In B, we are told water flows at a speed of 20 along a rectangular channel into a lake. The width of the channel is 15. The depth of water is 2.5. Give the amount of water that flows from the channel into the lake in 1 hour. So the amount of water is a volume. The amount of water, this means that they required volume in 1 hour. And when we have water flow, we can just consider the speed as sort of the height. the height of the prism. So this amount here. And we can simply think of the width and the depth here as the base area. But the speed is always the height. Whenever you have a water flow problem, the speed is always considered the height. So in this case, the width and the depth are multiplied together to give the area. So the base area, remember volume equals base area multiplied by height. The base area is going to be 15 multiplied by 2.5. And the height is actually the speed of water flow, which is 20. So we get the volume, but in terms of seconds or in terms of centimeters per second. So we get 15 times 2.5 times 20. And this gives us 750 centimeter cubed per second. So in each second, we get 750 centimeters cubed. We can do a ratio time to volume. We can say in 1 second, time in seconds, volume in centimeters cubed. So in 1 second, we get 750 centimeters cubed. We want 1 hour. So we multiply this number by 3,600. We multiply by 60 to get minutes, and then we multiply by 60 again to get hours. So here in this case, 750, we can put x underneath and cross multiply. So x equals 750 multiplied by 3,600. Or you can just think of it in terms of 750 centimeters cubed in 1 second. So in 1 hour, there are 60 minutes, each worth 60 seconds. So we have 60 times 60 times 750. This would give you the same answer anyway. So 3,600 times 750. We have 2,700,000. So the answer in terms of centimeter cubed per second would be 2,700,000 centimeters cubed per second. I will remind you of how to go from liters to centimeters cubed. We said 1 meter cubed and 1 centimeter cubed. There is a previous video in which we explained this, the advanced problems of areas and volume. And 1 liter here is in the middle. And to go from one to the other, you multiply by 1,000. So in this case, we're going from 1 centimeter cubed to 1 liter. So we're dividing by 1,000. So the final answer would be, cross out 3 zeros pretty much. So we want 2,700 liters. 2,700 liters is the correct answer here. In the final problem in this video, we have a cone with a radius of 1.75 and a height of 6. Calculate the total surface area of the cone. We mentioned before that calculating the total surface area is the same as coloring the shape from outside. So in this case, to color the cone, you're coloring the curved part, which is the curved surface area, for which we have this rule here, pi RL. But you also need to color the circular base from the bottom. So you need to color this part as well. So the total surface area is equal to the lateral surface area plus the base area. We are told that the radius is 1.75. So the base area would be pi r squared, and the lateral surface area is pi RL. So we're just missing L because that's the only unknown here. So how do we get L? We use the Pythagorean theorem. Let me erase the coloring so that you understand what I'm talking about. We want L, which is the slant height of the cone, which is this part here. This is L. And we are given this H here and this R. And we want to get L, so we use the Pythagorean theorem. L squared equals H squared plus R squared. So L equals root of 6 squared plus 1.75 squared. Use your calculator. You get 6.25. Finally, we plug the values into the equation. So pi multiplied by R, which is 1.75, multiplied by L, which is 6.25, plus pi multiplied by R squared, which is 1.75 squared. So you use your calculator, pi times 1.75 times 6.25. You get the answer for the first part, which is 34.36, plus pi times 1.75 squared, which would be 9.62. So the final answer would be the summation of these two numbers, 34.36 plus 9.62 gives us 43.98, which is obviously just 44. Therefore, the total surface area is 44, and the answer to BI is 44, so we are moving correctly so far. In double I, we're told the cone contains salt to a depth of 4.5. The top layer of the salt forms a circle that is parallel to the base of the cone. Show that the volume of the salt inside the cone is 18.9 centimeters cubed, correct to one decimal place. Now, the volume of salt is the shaded volume here, and this is a very weird shape, and you're not normally familiar with how to get the volume of this weird shape, except if you think of it in the following way. Think of it as a large cone minus a small cone. So the red cone minus the green cone gives us the shaded volume that we are required to find. So volume equals V big minus V small. So how do we get the volume of the big cone? Bear in mind that the big cone here is the same as the big cone in problem A. This is the same cone, except that the height here is given as 4.5 because they're only calculating the height from here to here, which tells us, of course, that the height of the remaining part, which is the small cone height, would be 1.5 because it's 6 minus 4.5. So anyway, the volume of the big cone, the volume of any cone in general, is 1 over 3 pi r squared h, and this is given in the problem of II-A. The volume of a cone is given right underneath question A. So for the volume of the big cone, we have everything we need. So let's just write it down. 1 over 3 times pi times the radius squared, which is 1.75 squared, times the height, which is 6, minus the volume of the small cone, which would be 1 over 3 times pi. And then we need to get the radius and the height of the small cone. This is where it gets a bit tricky. I would like you please to try to visualize with me this triangle here. This side here, this r small, is the radius of the small cone that we want. And this r capital is the radius of the big cone. This shape is a triangle inside a triangle, and these are similar triangles. So we have r small here and r capital here, and these are similar triangles. So how do we get r small? The target is to get r small. How would we do that? Bear in mind that this is h small as well, and this entire thing is h capital, which is the height of the big cone. So you can create a similarity equation between the small triangle and the big triangle. You can say r small over r capital equals h small over h capital. R capital is the radius of the big cone, which would be 1.75. H capital is the height, which is 6. We want r small and h small. Of course, we said that h small, which is the height of this cone here, the small height here is 1.5. We did this by doing 6 minus 4.5, so we subtracted. So this would be 1.5 here. And we want to get r small, we can just cross multiply. So 6r small equals 1.5 times 1.75. And then we divide by 6 to isolate the r. So 1.5 times 1.75 divided by 6 gives you 0.4375 or equals 0.4375. This is the small radius, and we can put it in to the equation. So 0.4375 all power 2 multiplied by the height, which is 1.5. And we can simply calculate each part on the calculator. So for the first part, we have 1/3 multiplied by pi multiplied by 1.75 squared and multiplied by 6. So you get 19.24 for the first part minus, again, 1 divided by 3 multiplied by pi multiplied by 0.4375 squared multiplied by 1.5, and you get the answer as well, which would be 0.30066, so just 0.3. So 19.24 minus 0.3 would be 18.94. And this is approximately equal to 18.9, correct to 1 decimal place. Therefore, our answer is correct, and we can move on. Part B says that the salt is removed from the cone at a constant rate of 200 millimeter cube per second. Calculate the time taken for the cone to be completely emptied. Give your answer in seconds, correct to the nearest second. So we already know that the volume of salt inside the cone is 18.9, and it is being removed at the rate of 200 millimeters cubed. Of course, you have to convert one of the units to the other. So 1 centimeter and 1 millimeter. You should know that to go from this to that, you just multiply by 10. So from 1 centimeter cubed to 1 millimeter cubed, you're going to multiply by 1,000. So therefore, the volume is equal to 18.9 times 1,000. And this gives us 18,900 millimeters cubed. Now to get the time, we simply divide 18,900 by the 200. So 18,900 divided by 200 gives us 94.5 seconds. So correct to the nearest seconds, that would be 95 seconds. Let's check the marking scheme. 95 as a final answer is correct. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.